All right, so we are going to work on our in-class review for exam 3. So this is going to be all about identities and solving some equations. And so we're going to start out with simplifying some trig expressions. We'll prove some identities, we'll find some exact values, and then we're going to use lots of the formulas. Sum to product, product to sum, half angle, addition and subtraction, whatever comes across the way that we're working these. And then we'll do some solving equations. So we'll solve the given equation, and then we're going to find all the solutions that happen between 0 and 2 pi. Alrighty, so here is our first problem. So for number 1, we're looking at secant x over cosecant x, and it just says to simplify it. So that's all we're going to do is simplify it. First thing we want to do is write everything in terms of sine and cosine. Secant is 1 over cosine, and cosecant is 1 over sine. Remember, we don't divide by fractions, we multiply by reciprocals. So let's look at as 1 over cosine times sine over 1. Well, if we just multiply that across, we get sine x over cosine x, and that will be equal to tangent x. All right, let's look at our second problem. The second one is 1 over 1 minus cosine x plus 1 over 1 plus cosine x. And again, we are just trying to simplify this. Well, the first thing we got to do is get a common denominator. So our common denominator is going to be 1 minus cosine x times 1 plus cosine x. So I'm going to write the common denominator first. And on the top I had a 1. So I have 1 times, on the bottom, I had to multiply by 1 plus cosine x. So you have to multiply the same thing on the top of your fraction that you do on the bottom. And then over here, I had 1 plus cosine x, so I have to multiply by 1 times 1 minus cosine x. That times 1 is not going to do anything. We would, if it was something else, we distribute it or look to see what we could do. But times 1 is not going to do anything. So we're going to have 1 plus cosine x plus 1 minus cosine x all over our common denominator of 1 plus cosine, it doesn't matter the order, and then 1 minus cosine x. I switched the order of the plus and minus, but it doesn't matter. Now what we need to recognize here is that 1 plus cosine x times 1 minus cosine x, that is the difference of squares in a factored form. So we're going to multiply that out, and we are going to get 1 minus cosine squared x. On the top, our cosines will cancel, and we have 1 plus 1 will get us 2. Now 1 minus cosine squared x, that is going to be equal to sine squared x using the Pythagorean identities. And then we can pull the 2 out and have 1 over sine squared x. And we can recognize that 1 over sine is cosecant. So this is going to get us 2 times cosecant squared x. And this would be our final answer. All right, let's go look at our third one. So for number 3, we are still simplifying. And we have cosine x times cosecant x over cotangent x. Now, the cotangent, a lot of people always want to put it 1 over tangent. But if you're trying to simplify these, you want to put everything in terms of sine and cosine. So we'll have cosine x, and cosecant is going to be 1 over sine x, and cotangent is cosine x over sine x. Well, if we put this, remember this is going to be over 1, we have cosine x over sine x divided by cosine x over sine x. Well, we can see that we have the same thing over itself, so it's going to be equal to 1. And you could stop at this point and say it's equal to 1, but if you don't see how that is, then you can continue. So we don't divide by fractions, we multiply by reciprocals. So cosine x over sine x multiplied by sine x over cosine x. Our cosines will cancel, our sines will cancel, and we still end up with 1. So you could stop here when you see that they are equal to each other. All right, our next problem we are going to prove. So we're on number 4. This one we're going to prove because we have two sides of our equation. So we have tangent theta plus cotangent theta is equal to secant theta cosecant theta. So we have to look at which side we want to do that's more complicated. We're going to do the left-hand side. So the left-hand side is equal to tangent theta plus cotangent theta. But what I want to do is come up here and see what am I trying to get to? Well, secant is 1 over cosine, and then cosecant is 1 over sine. So I always like to write my final answer in terms of sine and cosine so I know where I'm going. All right, so tangent is going to be sine theta over cosine theta, plus cotangent will be cosine theta over sine theta. Well, we have a fraction. We need a common denominator. Our common denominator be cosine times sine. Cosine theta, sine theta. All right, so on the top we had a sine theta, and on the bottom we multiplied by sine theta to get there, so I have to multiply on the top as well. Over here I had I have cosine on the top already, and I multiplied sine by cosine. So now I have sine squared theta plus cosine squared theta all over cosine theta sine theta. Well, sine squared plus cosine squared, we know through the Pythagorean identities that that is equal to 1. So I have 1 over cosine theta sine theta, and I'm going to split the fraction and get me 1 over cosine theta times 1 over sine theta. Well, that's exactly what our rewrite got us up here. And cosine, 1 over cosine is going to get us secant theta, and 1 over sine will get us cosecant theta. So now this equals the right-hand side. And we have proven that they are equal. All right, so the next problem that we are going to look at is finding the exact value of the expression. So we're going to be using our addition, subtraction, half-angle formulas, whatever we need to use. So we're looking at, for number 5, we have the cosine of 195 degrees. Well, the first thing we want to do is write this in terms of the angles we know on our unit circle. And we are going to write it as cosine of 45 degrees plus 150 degrees. These are two angles on our unit circle. Because we're looking for the exact value and not a decimal, we have to use things that we know. So you've got to find a combination of two numbers from the unit circle angles that add up to get you this angle. And now we're going to do the addition formula for cosine. This will be our S and this will be our T. So using that addition formula for cosine, we will get the cosine of s times the cosine of t minus the sine of s times the sine of t. And now we can use the exact values. The cosine of 45 degrees will get us the square root of 2 over 2. The cosine of 150 is negative the square root of 3 over 2 minus the sine of 45, square root of 2 over 2, times the sine of 150 will be positive 1/2. So square root of 2 times square root of 3 will get us the square root of 6, that is negative, over 4, minus square root of 2 times 1 over 4, and then we can rewrite this as negative square root of 6 minus square root of 2 all over 4. And that would be your final answer. And that is writing it in terms of exact values that we know from our unit circle. All right, let's look at number 6. We're using the same instructions for number 6. We are given that sine of 32 degrees, cosine of 28 degrees, plus cosine of 32 degrees, sine of 28 degrees. So what we got to recognize is we have the same two numbers. So this will be our s and this will be our t. Now you have to go match this to the formula. And if we go looking at our formulas, we're going to find that this is the addition formula for sine. This is what it would be equal to. So this will be sine of s, which is 32, plus t, which is 28. So we have the sine. If we add 32 plus 28, that'll be 60. And the sine of 60 degrees is going to be the square root of 3 over 2. So this one looks more complicated, but it's rather easy when you can match that formula. It's the sine addition formula. You just got to match what you see to what you have. All right, our next problem, we are going to write the product as a sum. So we have the sine of x cosine of 5x. So we've got to go write it as a sum, and as we match this to our product to sum formulas, this will be 1/2 times the cosine of x minus 5x minus the cosine of x plus 5x. So we've got 1/2. X minus 5x will get us cosine of negative 4x minus the cosine of 6x. We have to remember that cosine is an even function. So this will be 1/2 times the cosine of 4x minus the cosine of 6x. And I'm okay that you leave it that way instead of distributing your 1/2 through. I'm okay if you just leave it like that. All right, number 8, we're going to do similar. We're going to write the sum as a product. So we have the sine x minus the sine of 4x, writing the sum as a product. So if we're looking at the sum as a product, we have to match this to our formulas with sine minus sine. This will get us 2 times the cosine of x plus our 4x all over 2 times the sine of x minus 4x all over 2. So 2 cosine x plus 4x, that'll give us 5x over 2 times the sine x minus 4x, that'll get us negative 3x over 2. And we have to recall that sine is not an even function, so that negative sign is going to move forward. So this will be equal to negative 2 times the cosine of 5x over 2 times the sine of 3x over 2. And this would be your final answer, because those aren't going to reduce any further. All right, so our next equation, so these are just using our formulas, these last few. Just been using the formulas that we know. I told you on the lessons that those formulas will be available to you. I do not expect you to memorize all of those formulas. So we have 4 times the cosine squared theta minus 4 cosine theta plus 1 is equal to 0. All right, so this is something we're going to have to factor. So I'm going to use the AC method. So we're going to take A times C, trying to get to B. My A is 4, my C is 1, so 4 times 1 is 4, trying to get to negative 4. So if I start with 1 and 4, my bigger number has to be negative, and I need them both to be negative so that when I multiply I get a positive. So negative 1 times negative 4 is positive 4. When I add them I get to negative 5. Not quite there. So then negative 2 times negative 2 gets me a positive 4. When I add them I get to negative 4. Now you can also, if you want, so we're going to use this to do this part. You could rewrite your equation as 4x squared minus 4x plus 1 equals 0 and factor it this way. And when you get to your x equals, then you can transform that in. I'm going to work it, let's just work it both ways so that way you know what you can do to figure this one out. So what we would do is rewrite that negative 4 with these negative 2, negative 2. So we'd have 4x squared minus 2x plus 1 equals to 0. And then we factor by grouping. I can pull out a 2x and get 2x minus 1. Bring down my negative sign. I can only factor out a 1. And I get 2x minus 1 because I factored out a negative 1 from positive 1. We know we've done it right when these match. So we have 2x minus 1, and then grouping these two together, we get 2x minus 1 equal to 0. And then you would transform this back into cosine. I'm going to actually go factor it over here with just using the cosine so that we have, you could see it both ways. So we're going to do the same thing. We're going to write our negative 4 cosine with negative 2, negative 2. So we will have 4 cosine squared theta minus 2 cosine theta minus 2 cosine theta plus 1 is equal to 0. We're going to factor by grouping. So we'll pull out 2 cosine theta, and then we'll have 2 cosine theta minus 1 minus, because we have a minus sign, we can only factor out a 1, and we get 2 cosine theta minus 1. We know we did it right because these match. So we'll pull out our 2 cosine theta minus 1 and then group together what we have. 2 cosine theta minus 1 equal to 0. So notice we have the same answer except we made cosine an x value. So I could just then rewrite this right there with the cosine. I would be okay with either way. All right, now these are the same things. We only have to solve for one. So 2 cosine theta minus 1 equals 0. Add the 1 over, we get 2 cosine theta equals 1. Divide by 2, and cosine theta equals 1/2. Now, where does cosine theta equal positive 1/2? Well, that is going to be at theta. It'll be in quadrant 1 and quadrant 4. So theta will be equal to pi over 3, and theta will be equal to 5 pi over 3. So all solutions, remember that this is periodic. It is a period of 2 pi. So theta is equal to pi over 3 plus 2k pi, and theta is equal to 5 pi over 3 plus 2k pi, and k is any integer. So, are all solutions is what you're looking for? This would be your final answer. And I will not take off if you don't put the k as any integer, just so you know. It's good if you write it. You get a little smiley face there, but it'll be all right. All right, so our next problem is finding all the solutions of the equation. So we're basically doing what we just did, but we need to find the solutions in the interval, the interval of 0 to 2 pi. I got a little extra loopy there on the there. Sorry about that. All right, so here is our equation. We have 2 sine 3 theta plus 1 is equal to 0. So we're going to subtract 1 from both sides and get 2 sine 3 theta is equal to negative 1. Divide by 2, and sine, yikes, sine of 3 theta is equal to negative 1/2. So what we need to know and understand is that what is our theta going to be? So it's actually going to be 3 theta, and for this we would get 3 theta is equal to 7, because it's got to be negative, so it's going to be in quadrant 3 and quadrant 4. So it'll be 7 pi over 6, and 3 theta is equal to 11 pi over 6. So now we've got to solve each of these so that we can get it where we can use it. So I'm going to take my 3 theta is equal to 7 pi over 6 plus 2k pi, just like we did in the previous where we added the 2k pi, except here we had it solved for theta. This is for 3, so we've got to do a little bit more work. We also have 3 theta is equal to 11 pi over 6 plus 2k pi. So the first thing we're going to do is divide by 3. So that we end up with theta is equal to, we don't divide by fractions, we multiply by reciprocals. So when we multiply, this is basically 3 over 1. It'll be multiplying by 1/3, so we'll end up with 7 pi over 18. And then I want a common denominator, so I want this to be over 18 as well. So 3 times 6 gets me to 18, 2 times 6 will get me 12. Over here we have the same issue. We're going to have to divide by 3, and theta will be equal to 11 pi over 18 from the same principle as this one. We multiply by 1/3, and we'll have the same 12k pi over 18. All right, so those are the two solutions. Now what we need to do is find all of them in that interval of 0 to 2 pi. So first what I want to do is transform my 0 to 2 pi, and I need it to be with a denominator of 18. So first it's going to stay at 0 because it doesn't matter if you put it over 18, it's still 0. But to get 2 pi to 18, I need that common denominator of 18. So this would be over 1, so multiplying by 18. 18 times 2 will get us 36. So we'll have 36 pi over 18. So we know when we need to stop in that interval of time. Alrighty, so now we have to choose all of our k's to find out where they're at. So let's see if we can do it here. So if we try, let's see if we can fit them in on this side. So if we do k is equal to 0, we get theta is going to be equal to 7 pi over 6 plus 2 times 0 pi over, 12 times 0 pi over 18. And this should be 18, not 6. Sorry, I looked at the wrong spot. So 18 on both denominators. Times 0 will get us 0, so it's going to be 7 pi over 18. So that's our first angle. And what we do to this one, we're also going to do to the other one. So we will have, let me change colors here so we can see it. We have theta is equal to 11 pi over 18 plus 12 times 0 pi over 18. Again, this will be 0, so it'll be 11 pi over 18. All right, let's go do k is equal to 1. So theta is equal to 7 pi over 18 plus 12 times 1 pi over 18. Well, 12 times 1 is just going to be a 12. So 7 plus 12 will get us 19 pi over 18. And we'll do the same thing over here. So theta would be equal to 11 pi over 18 plus 12 times 1 pi over 18. 11 plus 12 will get us 23 pi over 18. All right, let's go try k equal to 2. So theta is equal to 7 pi over 18 plus 12 times 2 pi over 18. This one has a little bit more to it, so I'm going to actually rewrite that. So it'll end up being 7 pi over 18. 12 times 2 will be 24 pi over 18. And when I add those, I get 31 pi over 18. Do the same thing to the other one. We get theta is equal to 11 pi over 18 plus 12 times 2 pi over 18. So 11 pi over 18 plus 24 pi over 18. So when we add that, we end up getting 35 pi over 18. Now what we need to recognize is this is super, super close to our 36 pi over 18. And we can kind of see this went from 7 to 19. Well, it went up by 12. It went up by 12 again because we got 12 pi over 18. I won't be able to even take 31. I'd end up with 43 next. So that's over our 36. So those would be all of our solutions right there. We'll end up with 6 possible angles from that 0 to 2 pi for all of the, or not the angles, but that's what our theta is. Yeah, I guess they are angles. All of the solutions in that interval of 0 to 2 pi. So getting that common denominator helps you see when to stop.